Hi, welcome to my channel about robotics, physics and embedded systems. This video is focused on my Arduinos, and this is Arduino Mega2560, Arduino Mega80K and Arduino Uno, all programmed in C, with some electronics and a physics motor and the multimeter standing by for this Potmeter. Last time I decided not to use a second laptop, but to use this multimeter for measuring the exact value of this Potmeter, which goes both via the Uno to the 2560 and then to my laptop, and in a direct way. And that turned out to be a little bit different in value. So in order to know which value is set on the Potmeter, I need the multimeter to see why I read which value where. And of course I need some software to actually read it, and for that, to show you, I'll change now to screencast. Camera on the hardware, then top right corner the Arduino environment, below is the processing environment, in which I use Java for reading actually and storing things, and then the Genie environment for Fortran acquisition or data acquisition and preparing by Fortran. And this is part of the Arduino environment, the serial monitor. And to continue with this for now, I have to put these two probes with the Potmeter, but I have to do that in a nice way, which I didn't do last time, so I need some extra hardware for that. So let me find something. So I found a solution. First of all, this probe is obviously going into the ground, so let me put it right there. But then remains the red probe to measure the voltage, and for that I found this. Well, this was a longer wire, cut it short, and to use it I just will stick the probe into it. That means that I have to create some space here, so I'll move the Potmeter one port further, creating space. And then I of course have to try to insert this into it, but it is a little bit too thick, I'm afraid. Splitting the wires. And then see if it can fit. It will have to fit, otherwise this idea is completely useless, and I have to even split this part. Even less wires. Now it inserts, sort of. Potmeter. And the probe. And there it goes. Full scale. So 12 volts. 30 volts, full scale. 4 volts. And if I now turn the Potmeter, I can just bring it down and fully up. So that is settled. Now for the software part, how can I read anything nicely? So now the numbers, and that means that the numbers read here should be the same as the numbers read here. They're not. And because there's no computer linked to this one at the moment, I can't verify exactly the number, but I have to rely on this one. Having said that, this is a continuous flow of all values, but I can't use that right now because I have to read them from here to make a real thing happen. So this is the ordinary code, and why is this here? Should go. Not processed yet, so let me run this for 15 seconds, I think. Then I hope I'll have enough data to read with Fortran. On the other hand, previous experiences, as you can have seen in the previous videos, is not a guarantee at all. So hopefully this is enough. So let's stop this and then see how this works out. So run, and I have here a problem immediately in line 55. Something with this. Alright. Which I once again have to find out what it is and why. One quick look says bad integer for item 9 in the list input. Well, that is actually not line 55, but line 56, I'm sorry. And that is this one, I4, which is defined as integer of 9 digits. However, this one, which it is about, is 10 digits. So I'm afraid I'll have to create this one, quit, build, and do it again. Same thing. That's no good. Is it even possible to do that? Let's go back to 5. So how many numbers can an integer have in Fortran? That's a very good question then. If 9 is too much or 10 is too much, how far can I go? I'll have to find out. And now it becomes quite complicated and interesting at the same time, because this number is, as you can see, quite large. And it turns out that in Fortran you have integer and kinds of integers like 8 bytes, 16 bytes, 32 bytes and 34 bytes, bits or bytes. Anyway, I simply have to do it like this. And then I4 says, okay, now it is I4 or I23 or something. And that also means that I have to treat it differently. Or maybe not. Anyway, This is a different type of different kind of integer, obviously, than this one is. It's two different kinds. Can I treat it then differently to grab another part of it? I don't know yet. Anyway, let's see how this one turns out. And build and run. Same thing. And that was something I am not expecting. Most likely. Let me turn this into I23 then. And here also 23 and 23. 23 bits. And run. Same thing. Bad integer for item 9. So this isn't the solution after all. Okay, let me cut this out. And cut this one out. No, this one. Let's see what happens now. One, 2, 3, 4, 5, 6, 7, 8. There's no 9. Still line 55. Or am I reading wrong? No, this is line 55. It says line 55. So then, where exactly is it going wrong? That is a big question. Not quite sure. And now something is really very odd. It still gives at line 55 the same error. However, apart from the fact that I've now replaced all I4s by I32, I'm sorry, I also have right here commented out all others, so it's only the first thing, and still gives the same error. And line 55 is this, because I reinserted 4 for I4, which maybe should be 9. Apart from that, let me make it 8. Doesn't really matter. It still gives 55, which is very strange since 55 is now this one and no longer this one, let alone this line. So I'm very curious why that error happens. Very strange. Right, and I'll let Fortran for what it is. Now, back to what I started with. The potmeter and the probes for the voltage. Then the pointer says fully open or fully closed or something in between. But then reading the values either via the Uno or directly to the Niekerk 2560. That means that something has to go in here, which means Uno is digitized and this is not digitized, because this one has analog input and digital output, and this one is analog input. And if you look at the digits, they are not quite the same. and then I meet the last 4 digits, and that's what you should look for. The other ones, the first 4, or no matter how many there are in front of them, forget them. So, fully closed, quit or stop scrolling. Then once again, um, 930 926, okay, and right here also fully open. What's the difference? Again, between 50 and 60 difference, but what's the whole thing? It's only 4 digits, but how does it have a whole digit? That's a question that I am as yet unable to solve or to answer, but that is what I will try to do next time, and because I have to solve that before I can even solve this one. And finally, fritzing, nothing changed except the addition of the voltmeter, which is in this case is digital, but of course in reality for now analog. And with that, more next time. And this is continuously flowing, obviously. Maybe no, that's the best I can do, but that's for now. So thanks for watching. Well, different result than I had anticipated and hoped for, but at least something is now quite reliable. So if you like this video, please do subscribe to my channel, give the video a thumbs up, click the bell for notification. Please leave a comment or suggestion under the video. You can also follow me via Twitter and Instagram, and you can support via PayPal, Ko-fi, and by becoming a patron. Much more information on my website, so please take a look there. Also for other embedded systems projects and physics and robotics. This is obviously going to be continued. For now, stay safe, have a great day, take care, bye.